Hello friends, welcome to GSR ChemTube channel. Here we're going to discuss about atomic structure chapter, in that the discovery of fundamental particles. First let us see the discovery of electrons. Who discovered these electrons? The existence of electrons in an atom was first time shown by J. Thomson in 1897 by passing electricity at a high voltage through a gas at a very low pressure in a discharge tube. Here, what is a discharge tube? A discharge tube was invented by English physicist William Crookes. It consists of a long cylindrical glass tube sealed at both the ends. Here you can see a long cylindrical glass tube which is closed at both the ends. It is fitted with two metal electrodes at both the ends, and these metal electrodes are connected to a source of high voltage current. This discharge tube is filled with air and its pressure is controlled by a vacuum pump. From this, let us see the production of cathode rays. Thomson passed electricity at a high voltage through the gas at a very low pressure taken in the discharge tube. He detected that a stream of particles or rays was coming out from the negatively charged electrode to the positively charged electrode. These rays he called as cathode rays or electrons. Now let us see the properties of these cathode rays or electrons. These cathode rays travel in straight lines. They are independent of the material composition of the electrodes taken. Applying electric field in the path of cathode ray, they deflect towards positive charged plate. Hence, cathode ray consists of negatively charged particles. J. Thomson measured the charge by mass ratio or E by M ratio, which is also called specific charge of cathode ray particle, using deflection in both electric and magnetic fields. He found that the E by M ratio of these cathode rays or electrons is being minus 1.76 into 10 to the power of 8 coulombs per gram. The cathode ray particle turned out to be around 2000 times lighter than hydrogen. Although we got E by M ratio for electron from the J. Thomson's cathode ray tube experiment, we still don't know the exact charge of electron. American physicist Robert Mullikan designed an experiment to measure the absolute value of charge of electron. That is Mullikan's oil drop experiment. In 1909, Robert Mullikan conducted the oil drop experiment to determine the charge of electron. He suspended tiny charged droplets of oil between two metal electrodes, here as shown, by balancing downward gravitational force with upward drag and electric forces. By this experiment, he measured the charge of an electron as being minus 1.602 into 10 to the power of minus 19 coulombs. Now let us see the discovery of protons. The presence of positively charged particle in an atom had been first observed in 1886 by Eugen Goldstein. Based on the concept that atoms are electrically neutral, it means already electrons are discovered which are containing negative charge. So as atoms are being neutral, they should also contain some positively charged particles. While he was working with the cathode ray tubes, he found that in addition to the electrons that travel from the negatively charged plate, there were other rays that moved in the opposite direction to them, means from the positive electrode to negative electrode. These were called as anode rays or canal rays or positive rays. In 1909, Rutherford discovered proton in his experiments. Further, he postulated that hydrogen nucleus to be new particle, and he named it as proton, from the Greek word protos, which means the first. Let us see the properties of these anode rays or canal rays or protons. Anode rays travel in straight line. Anode rays are positively charged material particles. Anode rays may get deflected by external magnetic field or electric field. Unlike cathode rays, their EBM value or specific charge is dependent upon the nature of the gas taken in the discharge tube. It is maximum when the gas present in the tube is hydrogen. Discovery of neutrons. By 1920, physicists know that most of the mass of the atom was located in a nucleus at its center, and that is central core contained protons. In May 1932, James Chadwick announced that the core also contained a new uncharged particle which he called as neutron. He bombarded the element beryllium with alpha particles. So alpha particles he passed on to the beryllium atom to bombard that. Here it is happening. He observed that beryllium changes into carbon and thus neutrons are emitted from this reaction. Here alpha particles means helium ions or doubly charged positive ions, and these are emitted by radioactive elements. Properties of neutrons. Electrically, a neutron is neutral, means it has no charge. In a particular element, the number of neutrons in the nucleus of its atoms may vary. That means atoms of same element also may have different number of atoms in each. Comparison of the properties of these electrons, protons and neutrons, let us see in a chart. Here it is given the charges and masses of these three fundamental particles, electrons, protons and neutrons. If you observe the electron charge, minus 1.602 into 10 to the power of minus 19 coulombs, whereas the proton's charge is the same quantity but positive, whereas neutron has no charge. If you observe the mass of these particles, mass of electrons is very less when compared to the mass of protons and neutrons. It is 9.11 into 10 to the power of minus 31 kgs, whereas the proton's charge is 1.672 into proton's mass is 1.672 into 10 to the power of minus 27 kgs. A little higher for neutron. In terms of AMU also are given here. So the mass of proton and neutron has to be almost equal, but to say accurately, a slight heavier for neutron. Thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest